Thank you all for being part of the design review for this product. And as the chief engineer for it, I'm going to let you know what the results were. I've taken into account everything that was presented and added and come up with a final design solution for us to actually now start working on in depth, in detail. So these are the results of the design review. The first one is that we're going to add an inlet filter. A couple of people suggested that, and so I've got a design for one that I made just very quickly. We could probably do better, but it's going to be good enough for now. And that is going to be a 3D printed part because it would be very expensive to make in any other way, and failure of that part is not catastrophic. So that will be a 3D printed part. It's an inlet filter. Of course, that then requires some connection to the check assembly. There's the check assembly. We're changing the inlet check assembly to a 1/2 NPT female inlet by 1/2 NPT female outlet. The reason for that is that allows us to put in a very, very low force swing check that will open very easily so that when we push the piston up, there will be very little resistance of the water coming in. So that's a new check assembly, and it's a 1/2 female by 1/2 male. And we're going to change the hole sizes to eliminate bushings. So this will be a 1/2 NPT female here so that this 1/2-inch coupler will fit. So these are all purchased parts again, but it eliminates a lot of the difficulties, and it gets us the inlet filter. The other one that we're going to do is change this hole size on the top right up here so the piston tube screws in directly. That just becomes a 1/2 inch piece of pipe. So it's a 1/2 inch nipple, and the piston is going to sit right inside. I looked at some of the other concepts and designs, and the diaphragm is actually more difficult to manufacture, many more parts, and a little bit tougher to do. I think it would work probably maybe with fewer difficulties, but this will be an easier one to make. And the piston then has a spot for a strong spring on the return. So there were some other ones. The bulb idea was good, but it's unproven, and I don't think it will have the lift capacity. So I'm not having enough information to pull that. That's okay. The other is that we talked about, where is this going to be? This is going to be underwater on an ROV. If we need to get samples from a certain location, it just doesn't work to drop a line down and hope you're in the right spot with the currents and the snags. So we're going to go for full control, which means that this block has to be sized so that the arm can clamp on it from the ROV. So we've got some block changes. So we'll have a piston. There's an inset in it for a spring. This is just our tube again. And there's no piece coming off the end of the piston because I've gone with an air drive. Air will push in, down against the spring. We'll have plenty of air pressure so that we can create a large force. And then when we release that force, the spring will push back up. And we can adjust those forces because there were 16,000 springs to choose from. And we can get quite a bit of force pushing down on that area with up to a 90 pound per square inch air pressure. And air pressure will go underwater very easily. So there you have it. This side stayed the same. There's just a 1/4 inch NPT, the 1/4 inch female by 1/4 inch male check assembly. We'll put an outlet tube on here. And those are the changes. This does become the design we're going to work with. Thank you all for your input. It was very informative. And I need to talk about materials. This will be 3D printed PLA or ABS, brass or bronze fitting, brass or bronze check assembly, brass or bronze fitting. This is going to be a brass or bronze block again, so that's going to get machined. Brass or bronze, brass or bronze, brass or bronze, and this will be stainless steel. So we're going to have a few different pieces. PLA, mostly brass or bronze, and stainless steel. There we go. So thank you all for participating in the design review. This is the design that we'll move forward with. So next we need detailed drawings of these parts so that we can start manufacturing them.